In our previous video, we saw a couple of interesting things. First of all, we saw data types, both double and int, and we also saw mathematical operations, how we can perform a mathematical operation and then have an equal sign to the left of that mathematical operation, and then to the left of the equal sign have a variable declaration. In this video, I want to talk a little bit more formally about what each of these things are. This slide is on my website, and I'll include the link in the video notes for this. But essentially, what are data types? There are data types are how we convert those zeros and ones into the type of data that we want. So a string with letters, or a color, or a sound, or a picture, or anything like that. So first of all, we have the first grouping of data types are primitives. These are things that are pretty much mapped directly to zeros and ones in memory. In other words, a primitive has a size and amount of memory it takes up, and then it's going to interpret the zeros and ones in that memory into one particular fashion. So we'll take a deeper look at primitives in just a moment. Now, we can also have operators, which are the way we do math. We've seen that division is the slash on the question mark key, addition is the plus sign as you want. You might imagine subtraction is minus, and so on and so forth. The plus sign has a special use as well, because we saw in our toString method, it can be used not just to add numbers together, but also to concatenate strings together. So that one has a bit of a special use. Okay, we know we can combine primitives together and make a non-primitive data type, which would be a class or an object. We explored that a little bit in a previous video. If you take a look at our example, just a moment. Oh, there it is. If we take a look at our example in driver, we know that we have a variable called myVehicle of type vehicle. And vehicle is not a primitive type, it's actually a class. Okay, and then we know we can get interactive input from a user with JOption pane. Let's start by looking at data type. So data type, how we store data. Numbers without a fraction. So far we've used an int, and you see this has a range of minus 2.1 billion to positive 2.1 billion. Now what would happen if we had an int data type and we happen to add 1 to this number here? Well, essentially it would roll the odometer over and it would give us back a negative number, which is not the number that we want. So we have to pay special attention to the data type and the size that it consumes. The size is directly mapping to memory. So 1 byte means it takes 8 bits. Remember the binary calculator we saw a couple weeks ago. 2 bytes means it takes 16 bits. 4 bytes, 32 bits, and 8 bytes is 64 bits. So as we get more space, we can store a higher number. So there's a bit of a compromise here, which is we don't want to take up too much space, but we also want to allow ourselves a large enough storage area to store the number that we need. So I can give you a couple examples of where this has gone wrong. Back in 2005, Cincinnati was hit with a tremendous snowstorm that lasted about 3 days, dumped about 2 feet of snow and quite a bit of ice. Because of that, the airport pretty much shut down for a couple days. But it got worse because when they tried to reschedule the missing flights, Comair, which was at the time a regional air carrier based out of Cincinnati, Comair was unable to reopen because rescheduling the aircraft, the crew, the gasoline, the food, anything else that had to be scheduled, because of that snowstorm, there were more than 32,768 reschedules that were required. So they exceeded the amount of storage that they were allocated for their database, and as a result, their rescheduling system completely shut down. Even after the snowstorm was over, it took them several days to be able to recover and start operating again. So I remember reading this article in the Cincinnati Enquirer, and it mentioned this number 32,768 or 32,767, and I remember thinking that, you know what, that is the maximum amount that you can put into a 2-byte data type. So minus 32768 all the way to 32767. So they had exceeded the number of changes that they could save. Inevitably, I had someone who worked for Comair in one of my classes, and he told me that they were in the process of upgrading their rerouting system and their rescheduling system by the time that had happened, but they had not implemented it completely. Another one that I had, I used to have a job where I wrote a program that interacted with the Federal Reserve, and it would basically transfer money back and forth. And it computed a hash number, which was the first 8 digits of your routing and transit number, the number that shows up on the bottom of a checkbook. And the trick is that one time the payments had failed. One of the files that I sent failed for about $11 million because in summing up all of these hash numbers, it exceeded this amount of 2.1 billion. So the fix was simply to change it to a long. So int is without a doubt the most popular. You will occasionally see longs for the example that I mentioned before about when you're computing a hash number and you're adding a lot of big numbers together. Short, not very common anymore because, to be honest, we've kind of taken memory for granted now, and a lot of times 4 bytes isn't asking a whole lot. Byte you don't tend to see much either. Now, a couple interesting considerations. First of all, how do we make the difference between negative and positive? Well, the leftmost bit of each of these data storage mechanisms is just a negative or positive indicator. So that's just reserved. If it's a 1, it's negative. If it's 0, it means it's positive. Now, another thing is you'll notice, and I have a question here in red, you'll notice that the upper boundary that's positive is generally 1 less than the absolute value of the lower boundary. And why is that? Because we have to account for the number 0. If you have all of the bits set to 0, then the number is 0. And that essentially takes up one possible combination of zeros and ones. So from that, let's consider floating point types. Floating point types are meant to handle data that has a fractional component. Now, there is a consideration here that's an important one. If I divide 1 by 3, just a moment, let me bring out my calculator. If I divide 1 by 3, you're going to see that the answer is 0.333 continuous. But that's not truly 1/3. That's really all of these 3's over some fraction. In other words, if we were to make this a little bit smaller, that's not really 1/3. That's 3,333 10,000ths, if that makes sense. So there's a bit of an inaccuracy that's built in. If you're doing financial calculations, I wouldn't use float and double. I would use big decimal instead, because instead of storing the final result of the calculation, it actually stores the history of the calculation and can replay it. It makes it a bit more efficient. Also, if you're doing any GPS with a mobile device, a lot of times the significance of the location is hidden in, somewhere around here, these kind of middle digits here. So the accuracy of the location is down to several digits that are to the right of the decimal point. In that case, unless you're actually doing math, I would store GPS data in a string. So the first 6 primitive types we've seen are all numbers. The whole numbers and then the floating point types. The other 2 we have are character and Boolean. Character represents literally 1 character from the alphabet. A lot of times we'll use Unicode so that we can have up to 65,200 different characters. Now, why do we need that many characters? We require that for internationalization. Consider other languages that are not English that have other characters that we don't have in English. Boolean is very simple. Boolean means it's either true or false. We'll see a lot of use of Boolean when we get into if tests and also looping. So with that, let's take a look at a variable. Variable we've done before. We know that it has a name and a type. We see the primitive int and its name counter. We see here the class called char and a variable called char, which will hold an object of type char. Okay. One thing I want to explore a little more deeply is assignments and initializations. So in our example so far, we have initialized some variables. If we take a look at vehicle, what we're doing up here is the initialization step. Initialization is when we give a variable a name and a data type. Okay? Now down here we have an assignment operation. So an assignment operation is when we have the equal sign and we do some computation on the right, and assign that value to the variable on the left. So initialization up here and then assignment down here. Sometimes you'll find that both of those steps are combined into one line. For example, line number 30, we're initializing the variable to the left of the equal sign, and we are assigning the variable with what is on the right of the equal sign. So a very important note here. You can only initialize the variable once. And initialization, by definition, is the type followed by the name. You can refer to the variable by name later, but you cannot reinitialize it. In other words, if I wanted a string that represents the odometer, private string odometer, this wouldn't work because you see I've used the same name a second time. We're not allowed to do that. Now, if I change the name slightly, like called it str odometer, that would be okay. We can go with that, but we cannot reuse the same name. Okay, so that is a quick look at data types in Java. The next thing we're going to look at are the comparison operators, and we'll do that in a separate video. I'll see you then.